Welcome to the second season of Tech and AI. Enjoy the episode and please subscribe. Thank you.
Okay, so you've probably seen the viral clips, right? People bumping into walls with headsets on, maybe some cool-looking games. It's definitely got attention. But for anyone actually looking to use this stuff in business, the big question is, okay, beyond the entertainment, what can augmented and virtual reality actually do, like right now? Where's the real return on investment?
And that's exactly what we want to unpack for you today. Our mission really is to cut through the noise.
Yeah, less hype, more hands-on.
Precisely.
Yeah.
We're focusing on those specific, maybe quieter areas where AR and VR are already delivering solid value. Think factories, hospitals, classrooms, places where it's making a tangible difference today, not in some distant future.
Right. But before we dive into those specific cases, maybe we should quickly level set on the terms. Because VR, AR, MR, they get thrown around a lot. It's kind of a spectrum, isn't it?
It absolutely is. And picking the right tool for the job is crucial for that ROI you mentioned. So yeah, let's do a quick primer. On one end, you've got VR, virtual reality. That's the full immersion experience. Headset on, and your real surroundings are completely replaced by a digital environment. Think flight simulators, complex training scenarios. Total replacement.
Got it. Fully digital world. So AR is different.
Totally different. AR, augmented reality, doesn't replace your world, it adds to it. It overlays digital information like text, instructions, arrows, 3D graphics onto your view of the real world, usually through smart glasses or just your phone screen.
Enhancing reality, not escaping it.
Exactly. And then there's MR, mixed reality, which sort of bridges the gap. With MR, the digital objects don't just float on top, they actually look like they're interacting with your physical space.
Like a virtual object casting a shadow on your real desk.
Precisely. Or being hidden behind a real chair. It makes the digital elements feel much more integrated. So VR for full immersion, AR for real-world guidance, MR for that blend. The task dictates the tech.
Makes sense. So if you need to practice something dangerous, VR's your answer. If you need hands-free instructions while fixing something, maybe AR glasses.
You've got it. Okay, so let's jump into maybe the most critical applications first, where this tech is literally saving lives or preparing people for high-stakes situations.
Healthcare seems like a prime example.
It really is. In healthcare, the immediate impact is all about precision and better situational awareness, especially in surgery and clinical work.
Okay, tell me about the surgical side. I mean, visualizing complex anatomy must be a huge advantage.
It's game-changing. Surgeons are using AR now to overlay 3D models of a patient's specific anatomy derived from CT or MRI scans directly onto their view during surgery.
Whoa, so they see the patient, but also like a hologram of their blood vessels.
Exactly, or the precise boundaries of a tumor. It helps enormously with preoperative planning, letting them rehearse complex steps, but also gives real-time guidance during the operation. It's about seeing things you couldn't normally see.
That sounds incredible for precision, but hang on. If they're looking through something displaying data, doesn't that add a layer? Could it be distracting, or is there a lag? I mean, in surgery, timing is everything.
That is absolutely the critical challenge. The hardware has to be top-notch, super high refresh rates, minimal latency so it feels seamless, not like a delay.
Right.
But when it's implemented well, the benefit of that enhanced spatial understanding, that ability to see the unseen, generally outweighs the initial friction of using the tech. Right. Plus, the value isn't just in the OR.
Oh, where else?
Think about the ward. AR glasses can display hands-free checklists for procedures or guide nurses through setting up complex equipment. It cuts down on simple human errors, like forgetting a step in sterile technique, small things that have big consequences.
Yeah, but about talking to patients, explaining conditions can be tough.
Huge potential there. Imagine trying to explain diabetic foot complications using a brochure versus showing a patient a 3D interactive model they can turn around, see the nerve damage, the poor circulation.
Oh, yeah. That makes it much more real, much more tangible.
Exactly. It moves from abstract advice to something concrete they can understand and hopefully act on.
Yeah.
So better awareness for the clinician, clear communication for the patient. That's the core value.
Okay, shifting gears slightly. VR seems perfect for training in situations that are high risk but maybe don't happen often. Things you need to be ready for but can't easily practice.
You nailed it. Industries like aviation, firefighting, oil and gas, complex emergency medicine, they're seeing massive benefits.
Because you can simulate things that are just too dangerous or expensive to set up in real life.
Precisely. Think about simulating a cascading engine failure in a 747 cockpit, or a dangerous chemical leak in a refinery, or even coordinating a response to a mass casualty event. You can run these scenarios over and over in VR.
Building that muscle memory without the risk.
Exactly, and without the enormous cost of, say, staging a full-scale disaster drill. But the real power here, beyond just the practice, is the data.
Ah, right. It's not just about doing it, it's about measuring how you did it.
Correct. Traditional training often relies on an instructor watching and giving feedback, which can be subjective. VR training systems log everything, objectively.
Like what specifically?
Where the trainee was looking at any given moment, how quickly they reacted to an alarm, did they follow the procedure steps in the right order, where did they hesitate or make a mistake? All measurable data points.
And that's where the ROI becomes undeniable.
Absolutely. That data lets you standardize training across different locations, speed up the onboarding process because you know exactly when someone's competent, and even predict, based on metrics, who's ready for the real thing.
Right.
It's measurable proof of competence.
Okay, so moving from saving lives to saving money and time through efficiency, let's look at engineering, architecture, construction, that old saying, right?
Yeah.
An ounce of prevention
Is worth a pound of cure, especially in construction. The economic case here is crystal clear. Catching design flaws early is exponentially cheaper than fixing them later.
So how does VR fit in?
Architects, engineers, mechanical, electrical, plumbing, they're using VR headsets to do virtual walkthroughs of buildings before a single shovel hits the ground.
Like walking through the digital blueprint.
Exactly. Multiple stakeholders can be in the same virtual model from different locations and spot clashes. Hey, wait, this HVAC duct runs right through that main support beam, or these pipes are going to collide. Catching that virtually saves enormous amounts of time, materials, and rework costs later on.
And this connects to that idea of digital twin, doesn't it? Which always sounded a bit sci-fi, but sounds like it has very practical uses.
It does. A digital twin is basically a live, dynamic 3D replica of a real-world physical asset. Could be a whole factory, a building, even just a single complex machine like a generator.
Okay, so you have the real thing and this virtual copy that mirrors it.
Right, and it's often fed with real-time data from sensors on the physical asset. So using AR, a maintenance technician could look at a pump on the factory floor.
And see its data overlaid.
It's exactly. See its current temperature, vibration levels, its maintenance history, maybe even manuals or diagrams, all overlaid spatially right there on the physical pump. You're not looking at a separate dashboard. You're seeing the data in context. Ah, that's the pump that's overheating.
That seems way faster for diagnosing problems. But what if the real world changes? You know, someone reroutes a pipe and the twin isn't updated? Isn't there a risk of relying on outdated virtual info?
That's a definite challenge. Keeping the twin synchronized with reality is crucial. Data fidelity is key. But the best systems incorporate workflows for updating the twin. And importantly, AR also helps distributed teams collaborate on these models. They can quickly jump into a shared 3D space, review a prototype, make annotations, and resolve issues in hours instead of weeks of back-and-forth emails.
Right, speeding up those design reviews. Okay, so taking that digital model, the BIM, the building information model, or the twin, and using it directly on the construction site, that must be powerful.
Hugely powerful for on-site coordination. Picture a site foreman wearing AR glasses. They look at a newly built wall, and the glasses overlay the digital plan directly onto their view of the physical wall. It might highlight, hold on, this conduit is 20 centimeters off from where it's supposed to be, according to the plan.
Instant quality check. No need for measuring tapes and blueprints everywhere.
Exactly. They can run clash detection right there in the field. Will this pipe fit when the next trade comes in? Compare the plan versus the as-built reality and log any issues with photos and notes tagged to the precise physical location.
Fewer mistakes, less rework, tighter schedules. Makes total sense. Which leads us nicely into field service, right? Technicians out fixing things, often alone.
Yes, this is a classic high-impact AR use case.
Yeah.
Often less glamorous, but incredibly valuable. Think of a technician working on, say, a wind turbine or complex machinery in a remote location.
Often they might be relatively junior, too.
Right. So through AR glasses, they get visual prompts. Step 1, open this panel. An arrow points to it. Step 2, use this torque setting. The spec appears next to the bolt. It's hands-free, step-by-step guidance overlaid on the actual equipment.
Much better than juggling a greasy manual, especially if the manual isn't even up to date for that specific machine version.
Absolutely. And here's the real kicker. If they get stuck, if they see something unexpected.
They don't have to wait hours or days for an expert.
No need. They tap a button, make a video call, remote expert assistance. A senior technician, maybe back at HQ or anywhere in the world, sees exactly what the field tech is seeing through their glasses in real time.
And they can guide them?
Yes, and more. The remote expert can draw annotations, circle a component, draw an arrow, type instructions that appear directly in the field tech's view, locked onto the real-world object.
Check this valve here. Measure the voltage across these 2 points.
Wow, that's like having an expert looking over your shoulder instantly. The impact on uptime and first-time fix rates must be huge.
It is. Dramatically reduces travel costs for experts, gets equipment back online faster, and effectively shares expertise across the organization. But there's another hidden benefit.
Oh, yeah. The knowledge capture. Every one of those remote assist sessions, the video, the audio, the expert's annotations can be recorded and indexed.
So it becomes a training asset.
Exactly. The next time a similar problem occurs, another technician can search for and replay that exact fix step by step. It builds this amazing evergreen library of real-world troubleshooting captured organically, much cheaper and more effective than creating traditional training videos.
Okay, let's shift focus a bit towards enhancing experiences, how people learn, how they buy things, even how they heal, starting with retail and e-commerce. This feels like a big area, especially for tackling online returns.
You're right. Returns are a massive cost for retailers. And AR, especially mobile AR on phones, is directly addressing that buyer's remorse problem.
How so?
Think about trying to buy glasses or sneakers online. It's hard to know if they'll actually look good on you. AR lets you virtually try them on using your phone's camera.
Or makeup, right. See how a lipstick shade looks on your face?
Exactly. Or even bigger items previewing furniture. Will that sofa actually fit in my living room and match the rug? AR lets you place a true-to-scale 3D model right there in your space.
So you buy with more confidence.
Precisely. And when confidence goes up, returns go down. Even a small percentage reduction in returns, especially for bulky items, has a significant impact on the bottom line. We're talking potentially saving $10, $20, even more per returned item avoided.
And it's not just online, is it? It's showing up in physical stores, too.
Yes, enhancing the in-store experience. Imagine putting your phone at a grocery shelf and AR overlays pop up with nutritional info, maybe allergen warnings, or even personalized coupons based on your loyalty profile.
Like a digital assistant in your pocket.
Right. And for store staff, AR can help with tasks like checking if products are arranged correctly according to the planogram, the store layout plan from HQ. It ensures consistency across locations. So overall, higher conversion rates, better customer satisfaction, fewer returns.
Okay, now education and workforce training. We touched on high-risk VR training, but AR/VR seems powerful for just making complex ideas easier to grasp.
Definitely. The big win here is engagement and deeper understanding. It's about making the abstract tangible.
How does that play out in a classroom?
Instead of looking at a flat diagram of the solar system or a human heart, students can put on a headset or use a tablet and interact with a 3D model. They can grab planets, rotate the heart, look inside. It makes learning active, not passive.
I can see how that would make things stick better.
It really does. And for workforce upskilling, especially for hands-on tasks, AR provides that just-in-time guidance we talked about with field service. A new hire assembling a product can see instructions, animations, quality checks overlaid right on their workspace.
So they learn by doing, but with digital support wheels. Faster ramp up, fewer errors, less wasted material.
Exactly. And there's a significant accessibility benefit too.
Oh, interesting. How so?
Presenting information spatially, visually, and auditorily caters to different learning styles. You can have captions, text-to-speech, adjustable text sizes, different visual cues. It makes complex information more accessible to more people. When you can interact with knowledge, manipulate it in 3D space, it just resonates more deeply than reading text or watching a video.
Right. Okay. Back to the medical field, but from a different angle. Therapy and rehabilitation. This seems like a sensitive area, but potentially very impactful.
It is, and it's being used carefully but effectively. VR is particularly strong here for creating controlled, safe environments.
For things like exposure therapy.
Exactly. Treating phobias, fear of heights, spiders, public speaking, or even PTSD, a therapist can gradually expose a patient to triggering stimuli within a VR environment.
But in a way that's completely controlled and repeatable.
Precisely. They can adjust the intensity, the duration, and the patient always knows they can just take the headset off. It removes the logistical challenges and risks of real-world exposure while letting the patient build coping skills in a safe space.
Makes sense. And what about physical rehab? That often involves repetitive, maybe boring exercises.
VR can make rehab much more engaging through gamification. Instead of just lifting your arm 20 times, maybe you're in VR reaching for virtual targets, or balancing on a virtual pathway, or playing a game that requires specific movements.
So it motivates patients to stick with it.
Yes, adherence rates can improve significantly because it feels less like a chore and more like playing a game. There's also evidence VR can help manage pain perception, particularly chronic pain, partly through distraction, by immersing the patient in a different reality.
That's fascinating.
It is, but it's really crucial to add a major caveat here.
Okay.
This technology, especially in therapy and rehab, is an adjunct tool. It's something clinicians use to enhance their practice. It is absolutely not a replacement for trained therapists, doctors, or human connection and judgment. That's critical to understand.
Okay, so we've covered a lot of ground, 8 really solid areas where AR and VR are delivering value today. Healthcare, training, engineering, field service, retail, education, therapy. It's impressive.
But now we need the reality check, right? Because it's not magic. There are real limitations, risks, reasons why adoption isn't universal yet.
Absolutely essential to cover this, because these are often the reasons pilots fail or the technology ends up gathering dust. Let's start with the basics, the physical factors.
Comfort, I imagine. Those headsets can still be pretty clunky.
Exactly. Ergonomics is a huge one. We're getting better, but many headsets are still relatively heavy. They can get warm. Battery life is often limited. If a job requires someone to wear this for hours on end, it has to be comfortable, lightweight, and balanced. Fatigue is a real barrier.
And hygiene, if devices are shared.
Big concern, especially in training centers or on factory floors where multiple people might use the same headset in a day. You need strict cleaning protocols, easily swappable face pads, things like that. It has to be part of the plan.
Okay, physical comfort. What about the technical glitches, like motion sickness? That seems like a deal breaker. It can be. That feeling of nausea happens when there's a mismatch between what your eyes are seeing in VR and what your inner ear is sensing about your body's movement, or lack thereof.
So the tech needs to be really smooth.
Yes, you need high refresh rates, typically 90 frames per second or more, and very low latency, meaning minimal delay between your head movement and the image updating. Careful software design also plays a huge role in minimizing nausea-inducing motion. But honestly, perhaps the biggest failure point isn't the tech itself.
Oh, it's how it's implemented.
Exactly. Poor change management, treating it like a shiny new toy instead of integrating it properly into existing workflows.
Right. If it doesn't actually solve a problem or make a job easier in a practical way,
it won't get used. It fails if it's just a standalone gadget. To get that ROI we keep talking about, it must talk to the other systems the business relies on, like the Learning Management System, LMS, to track training results, or the Electronic Health Record, EHR system in hospitals, or the Maintenance Management System, CMMS, in a factory to pull up work orders and log completed tasks. If the AR/VR tool can't seamlessly connect via APIs, get data in, send data out, it's an island. And islands don't usually survive in enterprise IT.
that integration piece sounds absolutely critical and probably underestimated. What about data risks? These things are mapping physical spaces, right?
Huge issue. Spatial computing, by its nature, collects incredibly detailed data about the real world, the layout of your office, your factory floor, maybe even your home if used there. Potentially biometric data from the user, too.
That sounds sensitive.
It is. So clear policies around data privacy, user consent, data storage, and access control are non-negotiable. You have to address upfront. Who owns this spatial data? How is it secured? How long is it kept? What are the risks if it's breached? It needs careful handling.
Okay, one last potential pitfall. Keeping the content up to date. 3D models aren't like Word documents, are they?
Not at all. Content creation and maintenance is a significant ongoing cost. A 3D training simulation for a machine needs to be updated if the real machine gets modified, or if safety procedures change.
Otherwise, the virtual training could be wrong, even dangerous.
Precisely. So
Yeah.
you need a budget and clear ownership for keeping those 3D assets and virtual workflows synchronized with reality. It's not a one-time build, it's continuous upkeep.
Right, that's a really important dose of reality. So for someone listening who's thinking, okay, despite the challenges, I see potential here, what's the practical advice? How should they start exploring this, like a mini buyer's guide checklist?
Okay, rule number 1, start small and focused. Don't boil the ocean. Don't just say, let's do something with AR.
Define a specific problem first.
Exactly. Pick one clear job to be done, one specific pain point, and set a measurable goal. for instance.
Right.
We want to use AR-guided instructions to reduce errors on assembly line task X by 30% within 6 months. Be that specific.
Okay, defined problem, measurable goal. Step 2.
Match the tech to the task, like we discussed earlier. Is it hands-on work needing free hands, probably AR glasses? Is it deep immersion training for a complex or dangerous task, likely VR? Is it a quick visualization or customer try-on? Maybe just phone-based AR is enough?
Right, tool for the job. And then, thinking about those pitfalls we just discussed.
Prioritize the human factors during selection. Comfort is key. Look at weight, fit, adjustability. Hygiene solutions are crucial for shared devices. Asked about swappable components, cleaning procedures.
And the integration.
Yes, grill the vendors on integration. Ask tough questions about their APIs. How easy is it to connect to your existing systems? Does it support single sign-on? SSO. Can you easily export the usage data and analytics into your own reporting tools? Don't accept vague answers.
Okay, so problem defined, tech matched, usability checked, integration confirmed. What's next?
Pilot small. Run a limited test with a specific group. Document everything, what worked, what didn't. Gather user feedback. Track those metrics you defined up front.
Prove the value before scaling.
Exactly. Identify the blockers, figure out how to solve them, then make the case for a wider rollout based on real data. Without defining and measuring success up front, you'll never be able to demonstrate that crucial ROI.
Makes perfect sense. Okay, looking just a bit ahead then. What are the near-term trends we should expect? What's coming next that will make this even more practical?
On the hardware side, the relentless march continues. Headsets will keep getting lighter, more comfortable, with better displays, higher resolution, wider field of view, battery life will improve, and critically, expect much better pass-through quality.
Pass-through, that's seeing the real world through the headset cameras for MFR.
Right. As pass-through gets clearer, faster, and more realistic, the line between AR and VR blurs, making mixed reality much more convincing and useful. The digital overlays will feel truly integrated with your physical space.
And on the software side, AI must be playing a big role.
Huge. Expect AI to become much more proactive within the experience.
Yeah.
Think of AI agents that understand the context of what you're doing. Like the headset, using computer vision to see you're performing a maintenance task, realizing you missed a step and prompting you. Wait, you skipped step 4. Remember to check the pressure valve first. Or flagging a potential safety hazard based on what it sees. It becomes a truly intelligent assistant.
Wow. Context-aware guidance.
Exactly. Plus, we'll see more standardization in how 3D content is created and managed, making it easier and cheaper to build and update these experiences. Less friction on the content side. Hashtag tag outro.
This has been incredibly insightful. So just to quickly recap, AR and VR aren't just future tech. They're delivering measurable value today in critical areas, improving surgery, making high-risk training safer and more effective, streamlining design and construction, boosting field service, changing how we shop and learn, and even aiding therapy.
That's right. But we also saw that success isn't guaranteed. It really hinges on tackling those practical challenges head-on.
Deep integration into workflows, not just adding a gadget.
Prioritizing user comfort and ergonomics, especially for long durations.
And having clear, measurable goals from the outset to prove that ROI.
Get those pillars: right focus problem, right tech, solid integration, user focus, clear metrics, and the potential is enormous. Start small, prove it, then scale.
You know, so much of the narrative around this tech has been about escaping reality, about entertainment, the metaverse. But what really comes through from our discussion is that maybe the most profound value, right now anyway, lies in augmenting our current reality, making work, learning, healing just better.
That's the perfect takeaway, I think. The ultimate goal here for these practical applications isn't just building separate virtual worlds to escape into. It's about using spatial computing, this ability to blend digital and physical, to make our actual reality, how we work, how we build things, how we learn, how we care for each other, safer, faster, smarter, and more effective.
So the final thought for you, the listener.
Yeah, ask yourself, beyond the hype, how could you leverage this capability? Not necessarily to escape your reality, but to enhance it. How could spatial information or collaboration make what you do every day tangibly better?
Find that one job to be done. Apply what you've learned today and see where it takes you. Thanks for diving deep with us.